All right, so somebody asked me to make a video about synthetic division, so I had to go back into the memory banks a little bit and do this. So here's the sample problem I received. It's negative x to the fourth plus 5x cubed plus 6x squared plus 3. And we're trying to test x equals negative 6 as a solution. And essentially, we're going to divide that out rather than using long division. And we're going to use synthetic division as kind of a shortcut to divide these two things. Okay. Really, what we're trying to do here is we're trying to figure out if x plus 6. Okay, so if x is equal to negative 6, then we know that x is equal to, or x plus 6 is equal to 0. You're going to have to forgive. I got a new board, and I haven't been able to get it calibrated correctly, so I apologize for that. So we know that x plus 6, oh man, is a factor. Let's try using my... Oh no, nothing is working here. Well, we'll have to go with this. So we know that x plus 6 is a factor. So essentially what we're trying to do is we're trying to figure out if this x plus 6 piece, right, this piece right here, if this piece can be factored out of here. And if so, what would be the remaining part? All right, so we're going to use synthetic division in order to do this. So we know that x is equal to negative 6 as a solution. So I'm going to list the coefficients of the original equation out. So I'm going to say negative 1, okay, we have 5, that's x to the third. The coefficient of 6 of x squared is going to be positive 6. Then we've got 0 x's, so we have to make sure that we include that one in here too. So we have 0 x's, and then we have a positive 3 of x to the 0, which is 1. Okay, and then we know we're dividing this by x is equal to negative 6. Okay, now what this is saying is really what we're sort of doing with this is the idea of long division, right? This idea of where we took x plus 6, okay, and then we divided these pieces out and we got a remainder and we put it over x plus 6. This idea of synthetic division does that same thing, but in just a shortcut version. All right, first thing we do is we always pull the first coefficient straight down. Okay, and then we're going to just multiply. So we're going to take negative 6 and we're going to multiply it by negative 1 here, and we get a positive 6, and that result goes underneath the 5. Okay, from there we then are going to add those two together. So we're going to get 5 plus 6 is going to give us 11. All right, so we got 11 here, and then after we get 11 there, we're going to go ahead and multiply that by negative 6, which is going to give me negative 66. I gotta draw slowly apparently. So negative 66 plus 6 is going to give me a negative 60. All right, negative 60. And then if I take, let's see, negative 60 times 6 is going to give me 360. Okay, and I'm going to add those together and I get a positive 360. Okay, and then 36 times negative 6 is, I believe it's going to be negative 2,160. Okay, that these two are going to get added together now, and I'm going to get a negative 2,157. Okay. So what all these numbers mean? All right, as we do this, what we're doing here is we're getting our coefficients for each of the values after we've divided it by x here. Okay, so we're going to decrease each time, right? Because this is an x plus 6. We're going to decrease each of these. Let's see. We're going to decrease these by 1. Okay, so that we know that this is going to be negative 1 x to the third, okay, and then we're going to get plus 11, and we're going to decrease our the exponent on that by 1, so it's going to be x squared, okay, and then we're going to take minus, and we're going to do 60, and that's going to be x, okay, and then we're going to add 360, and I ran out of room here. Okay, so I'm going to go underneath here, and then we're going to be subtracting, okay, and what we're going to get is 2157, okay? But this is the remainder, right? So it's the remainder of whatever I divided by. Well, I was dividing by, right, when x is equal to -6, so I'm dividing by this. So those are the pieces I'm dividing by, which gives me the denominator of x plus 6, okay? Because this is what I was dividing by. This -6 over here, this thing right there, that -6 is what I was dividing by, so that factor would be an x plus 6. Okay, if you want more into the depth of as to why this works, it's really just kind of a shortcut, but there are a couple of good Khan Academy videos. You can just kind of Google why does synthetic division work. Hopefully this one explanation does help. The nice thing about synthetic division is a lot of times what we use it for is to test solutions. So we'll look to see, okay, is -6 a true factor of this, right? So does it make it a perfect factor? A perfect factor meaning like this end result is the remainder, you get a remainder of 0, right? So you'll talk about that after you learn how to do this. You talk about the remainder 0 theorem, and that's a way of using this idea to find factors of complex polynomials. So hopefully this helped.